Okay, what we're going to look at now is what we call plane sailing. Now, plane sailing is a method of determining the course and distance between two places which are not on the same parallel of latitude. The track that the vessel follows is called a rhumb line because it's plotted as a straight line on the chart. It cuts all the meridians of longitude at the same angle since the course is constant, and this is a principal reason why we're able to use it. So let's have a look how we derive the formula. In the figure here, the d-lat from A, this is our position here A, and we want to get to position B. So the d-lat from A to B is the arc of the meridian AP. So this is the circle our latitude position there. Okay, this is our parallel of latitude here, and this is our equator here. This is the equators here. We're at 10 degrees north here. Okay, so what's happening is we're going from this position here to that position there. We're going from a latitude 10 degrees north to a latitude 8 degrees north. So the d-lat is from A to, well, the d-lat is from A to B, but we actually measure it AP, that distance there. The d-long from A to B is the angle ANB. So this here is the d-long. Okay, and it's between these two meridians, SA, XPN and SQYBN. Okay, so that will be our d-long. Now if the vessel took the route A to P to B, then the departure would be PB. If the vessel took the route A to Q to B, then the departure would be AQ, and you can see there's a difference in size between the two departures. So what we do here, we call the true departure halfway between the latitudes, and that becomes known as our mean latitude. So the mean latitude is halfway between the given latitudes. Okay. With plane sailing, this is satisfactory precision-wise up to a distance of 600 miles. Above 600 miles distance, we couldn't use the plane sailing formula. So for the purposes of plane sailing, we assume it's the distance xy, which is exactly halfway between the latitudes A and B. This is called the mean latitude. And what we do, we carry forward the formula from parallel sailing, and the formula is departure equals, well, in parallel sailing we called it departure equals d long times cosine latitude. Now we've introduced the word mean, so departure is d long times cosine of mean latitude. So let's look at the plane sailing triangle. This is position A here, and we want to get to position B. So this is going to be our difference in latitude, and this is going to be our difference in longitude, and of course that's the course, and that's the distance between A and B. Now we want to find our departure, so departure is d long times cos mean lat. Now if we look at the triangle here, we can say that the tangent of the course is departure over d lat, because that's opposite over adjacent, and we can also look at the sine of the course adjacent over hypotenuse, opposite over hypotenuse, and the cosine of the course, which is of course adjacent over hypotenuse. But we'll just look at that a bit further over the page. So the formula that we use are these two here, and these are on your formula sheet. So first of all, we've got departure equals d long time cos mean lat, which we used in parallel sailing as cos lat, and now we're introducing it into plane sailing. Tangent of the course is departure over d lat. So now we're not talking about d long now, we're talking about departure that we have to calculate, and distance is d lat over cos course. So let's have a look at a drawing I've done here, and we're going from A to B, and this is our course and that's our distance. So if this is our course there, theta, then opposite that, this opposite side, is departure. On the adjacent side is d lat, and the hypotenuse is the distance. and we know that tangent of the course is O over A, opposite over adjacent. So looking at that triangle there, that right angle triangle, we've got departure over d lat. Cosine of the course is d lat over distance, again adjacent over hypotenuse, and by transposing that we can say that distance is d lat over cos course. And that's how we've derived the formulas, and they're the formulas that we use. So if you know position A and position B, you can calculate the d lat and the d long, and you can get your mean lat. You can then calculate your course and distance using the formulas. If you know your initial position, your course and distance, you can also calculate your final position by transposing the formulas. So, in plain sailing, if position A and position B are known, we want to calculate, say, the course and distance. So what we do, we obtain our d lat, d long mean latitude. First of all, we calculate the departure, which is d long times cosine of mean latitude. Then we calculate the course. Tangent course is departure over d lat. And then finally we calculate the distance, which is d lat over cos course. So here's a drawing here, course and distance measured there, and I've actually drawn a small globe there, if you like, indicating going from A to B. And then that gives us your adjacent, your opposite hypotenuse. Your initial position A is known. If your course and distance is known, you can find B, which is your final position. And to do that, you use the formula distance equals d lat over cos course. You transpose that. Because you know your distance and your course, you can find your d lat. Then once you've got your d lat, you can calculate your mean latitude. Use the formula, then use the formula departure equals d lat times cos course. Because you've got your course and you've got your d lat. Then finally, we get our departure is d long times cos mean lat, so we can find the d long. So what we've done here, initially we found the d lat, then we've had to find the departure, and then by using the departure and the mean lat that we've calculated, we can find our d long. Then we apply the d lat and d long to find our final position at B.